All right, let's moving on to the calorimeter. So calorimeter is an instrument used to measure energy changes, okay, associated from a chemical reaction or physical changes. All right, so look at right here. So this is like a layout of or the cross section of the calorimeter. Okay, if you look at the wall of the calorimeter, it's really thick, and the reason is you need to be able to keep the heat inside the system, right? Don't let the heat coming out because we want to measure the heat changes. For example, so if you put a hot object, right, or do a reaction that produce heat, the heat will transfer from the object or the reaction to the water, and we want the whole heat transfer to the water. We don't want heat lost from the system, basically. Okay, so from here. So that's why the wall is thick, right? Keep the heat inside. And all right, so the heat transfer to the water, the thermometer recognize that, so the temperature goes up or goes down, depends on the type of reaction. Okay, so we can write that the reaction has losing heat and the water is gaining heat, so negative and positive, or could be a vice versa. All right, from this equation, you can it allows you to find the heat transfer, how much heat is transferred in the system, and the specific heat capacity of that object. I'm going to show you how to do it. All right. In the lab, some of you take the lab, a common general chemistry one lab, the student will get to use the calorimeter as a two styrofoam cup with a cap on. I got a stirrer, got a thermometer, and got a water inside, and that works just fine. Okay, not a truly isolated system, but at least it keeps the heat inside long enough to be able to, for you to be able to communicate the heat change. Okay, all right, so there are two applications from using calorimeter. So calculate the heat transfer in right here and the specific heat capacity of this object. I'm going to show you. All right, one, determine the energy transfer. All right, so let's say we do aluminum and water. Here's the experiment. Usually the Gen Chem lab usually do this. So let's say we heat up the aluminum, right? So aluminum with a test tube filled with water down here in a beaker, and it's this thermometer. You heat up this water. So let's say the water boils at 100 degrees, right? So the whole system is 100 degrees. The aluminum will also have right at 100 degrees as well, because the whole system is 100 degrees. That's the maximum maximum temperature that water can hold. If it go over 100 degrees, water vaporize already. All right. So basically, my point is, doing this, your aluminum the temperature of your aluminum will be at 100 degrees Celsius. Okay. Once the aluminum is hot as 100 degrees Celsius, we dump the aluminum into this system. All right. So this is the calorimeter. Close the cap. All right. So hot aluminum will lose the heat to water. Does it make sense? All right. The calorimeter will keep the heat inside here, and there's no heat lost here. So the heat will transfer from aluminum to water. So the water gets hotter, and the temperature, the thermometer will recognize that. So we have at equilibrium. Everyone will be at temperature of 26 degrees Celsius, both aluminum and water. Okay, this is at equilibrium. All right. So how much energy it transfer from aluminum to water? You can do this calculation. I'll take a look. So one it lose. So aluminum lose heat, water gains heat. Okay. So they're just basic the law of conservation of energy. Okay. All right. So on the water side, so we know everything about water. So ms delta T, so mass of water, specific heat capacity of water, and so we know that's like mass of water, and delta T is the temperature changes from 23 to 26 degrees Celsius. Okay, so mass of water 130.0 grams. Specific heat capacity you can look up on the internet. You can look up on this handout. And delta T change, so 26 minus 23, so T final minus T initial. Don't switch that. This is always T final minus T initial. I'll show you why. So 3 degrees Celsius. Do the math there. So gram cancel with gram, degrees Celsius cancel out. You should get that number. Times -1 on both sides, so you're gonna get Q aluminum. So the heat of aluminum loses heat by that how much? Okay. Let's do scientific notation. 1, 2, 3, 10 to the third. That's kilo. I can put kilo right there. That's 10 to the third. And what's the sig fix here? 2 sig fix. Round them down, you get that number. Okay, so with this equation, it allows you to determine the heat transfer from one object to another. In this case, it's aluminum to water. And now you can also be able to find the specific heat capacity of aluminum, right, or any object you use in this system. Okay, all right. So to do that, well, aluminum loses heat to water, right? It loses that amount of heat. So we can to find the specific heat capacity of aluminum. So we have to go to the specific heat capacity equation. So Q aluminum equal to MS delta T. These are all aluminum, right? Not water anymore. We're done with water. Now, specific heat capacity. So we're going to move M and delta T to the other side. Look like that. All right. And the rest, guys, just plug in. So heat change, negative 1.6 kilojoule. But I'm not going to plug this number in. I'm going to use the one that before rounding off. If you remember, every time we round off, we add the uncertainty to the number. Okay, we're not going to do that. So I'm going to keep the tail right there and in kilojoule. Our mass of aluminum is that mass. Delta T, watch out. So delta T aluminum is a little bit tricky here. So start out, aluminum is hot. 100 degrees, right? So 100 degrees right there. Put in water, so the temperature of aluminum drops to 26 degrees. The whole thing is 26 degrees. Everyone has a temperature of 26 degrees. So the T final is 26. T initial is 100. 26 minus 100 is negative number. You get a negative number there. So watch out there. Plug in here is negative number. Okay. And without the negative number here, it won't cancel out with the negative up here, right? Because aluminum loses heat, the temperature have to goes down, right? Has to go down. If the aluminum loses heat, the temperature goes up. That doesn't make any sense. Okay, so negative here too. All right, the rest, just do the math right there. You should get this number. Kilo is 10 to the third, so I convert kilo to 10 to the third right there. 10 to negative 4 times 10 to the third, so you get 10 to negative first. And so just put negative 10 negative first in there and move the decimal to the in front of 9, so you get that number. All right, now the last one, significant figure. So 3 sig fix, make it 3 sig fix, write them down, you get that number. Okay, all right, let's review real quick. So the application of the calorimeter is one, determine the heat transfer, in this case from the object to water, right? And you are also will be able to calculate this for the specific heat of the object. Okay, so use just that equation, you can do that. And Q water, one loses heat, the other one gains heat. Q water, again, so it's just specific heat capacity equation, so MS delta T, all water, did that. And Q metal is all metal. All right, I'll have you do this on your own first try. Just try it out and then check with me on the next video, okay?